Hello everybody, BlackEyedGhost here with another linear algebra video. In order to understand this video, it'll help to know what a vector is. In this video, I'll be talking about vector addition and vector subtraction. In order to add or subtract two vectors, they both need to be members of the same vector space. When you add or subtract two vectors, the result is also a member of the same vector space. In order to add two vectors together, you'll take each component of the first vector and add it to the corresponding component of the second vector. This will give you a new vector with the same number of elements in it. Similarly, when subtracting vectors, you'll take each component of the first vector and subtract the corresponding component of the second vector from it. This also gives you a new vector with the same number of elements. Here's a quick example. Let's say we have the vectors 7, 5, 4, 6, and the vector 2, 3, 4, 1. We can add them like this. 7 plus 2 is 9, 5 plus 3 is 8, 4 plus 4 is 8, and 6 plus 1 is 7. If we wanted to subtract instead, we can do it like this. 7 minus 2 is 5, 5 minus 3 is 2, 4 minus 4 is 0, and 6 minus 1 is 5. Using the arrow representation of vectors, we can visualize vector addition and subtraction. Let's start by adding the vectors a and b. We start with vector a and draw b from its tip. By drawing a vector from the base of a to the tip of b, we get our result. Vector subtraction is very similar. We start with a and we draw b so that the tips of the two are connected. By drawing the vector from the base of a to the base of b, we get our result. Just like normal addition, vector addition is commutative. This means that a plus b is the same thing as b plus a. Going back to our visualization, you'll see that if we start with b and draw a from its tip, we still get the same result. This gives us two ways to represent vector addition, a at the tip of b or b at the tip of a. Let's look at a special case of vector subtraction, the 0 vector minus another vector. Same as before, we put the tips of the two together and draw the result from the base of the first to the base of the second. You'll notice that in this case, the result is the same as b, but it's pointing in the opposite direction. Since the 0 vector minus a vector is the same thing as the negative of that vector, this gives us a good way to visualize the negative of a vector. Vector subtraction is anti-commutative. This means that a minus b is equal to negative b minus a. Visually, all this means is that when you swap the order of a and b in the equation, the direction of the result also swaps. If we take the equation a minus b equals c and rearrange it, we can get a equals b plus c. Going back to our visualization, we can draw b plus c, and we'll see that we do, in fact, get a. This gives us a second way to represent vector subtraction. This way, we draw the bases together, and the result is drawn from the tip of b to the tip of a. If we compare this method of drawing subtraction to our previous method, you'll see that we still get the same result. Well, that's it for this video. Catch you guys next time.